Hi everyone, we're going to learn how to find scalar products and magnitudes. It's pretty easy, and these are the two vectors I have written in I and J and the two different vector notations. So the first thing we want to do is do the scalar product, and we're going to multiply 3 times my vector here. So basically all you do is you multiply 3 times your vector, which is 2i plus 3j, and that's going to yield 6i plus 9j, or you could write it as 6, 9 as the vector, all right? And then this one, we're just putting things together. It's 2 times your vector, 2i plus 3j, and minus 3 times your w vector, which is 3i minus 4j, and then you're going to just combine everything. This is 4i plus 6j minus 9i plus 12j, and you can combine everything. So this would be 4 minus 9i, which is negative 5i, and then we'd have 18j. I just combined my i's and j's. And if you want to write it this way, that would be negative 5, 18. Now the magnitude, remember, is the length of the vector, and all you're doing is going to, we're going to take the magnitude of the vector v, and simply it's the square root of 2 squared plus 3 squared, which equals the square root of 13. So what we're going to do is start out with some simple. I'm going to mainly concentrate on finding the magnitude, and then we're going to do more complicated problems. And I'm going to do about 12 problems. So we're going to do quite a few of the magnitude ones. I'm going to go quickly over those, and then we will get into more complicated ones. So for the first one, we have v equals 3i minus 4j, and I want to find the magnitude of v. So basically, that's just going to equal the square root of 3 squared plus a negative 4 squared, which equals square root of 25, which equals 5. Okay, you see how simple this is? Let's do this one. Negative 5i plus 12j. I'm going to find the magnitude, the length. That's just going to be the square root of negative 5 squared plus 12 squared, which gives you a square root of 169, which equals 13. And then we have v equals I minus j. And so the magnitude would be the square root of 1 squared plus negative 1 squared, which just equals the square root of 2. And then we have, let's see, let me scoot down a little bit. We have negative 2i plus 3j, so that's just going to be what? Negative 2 squared plus 3 squared, which equals the square root of 13. And let's do one more. We have 6i plus 2j, and to take the magnitude of that, we get, I forgot that. We're going to get 6 squared plus 2 squared equals the square root of 40, which, recall, can be written as the square root of 4 times 10, which equals 2 square root of 10. Now we're going to do some combinations of everything. and do a few of those. So a little harder, but they're still pretty easy. Okay, so what we want to do next is find 2v plus 3w. All right, and first of all, I need to give you the problems for this. So this one would be, let me find it real quick. All right, so for this, we're going to use v. For the rest of the problems, we're going to use this v equals 3i minus 5j, and we're going to use w equals negative 2i plus 3j. And we're going to find the magnitude, use scalar products, and do a combination of things. And we have 6 problems we're going to do. So the first one we're going to do is 2v plus 3w. And that's going to be you just multiply and you get, let's see where we're going to get, just a minute. Okay, I got it together. So what we're going to do is just multiply 2 times v, which would give us 3i minus 5j, plus 3 times w, which is negative 2i, plus 3j. And when you put this together, you're going to get 9i. Wait. This is 3v. No, we're on the wrong one. So this would be 6i minus 10j minus 6i plus 9j. This is plus. So these two cancel, and you just get negative j. Okay, and then, so just remember when we do these are our 2 vectors. Okay, the next one we're going to do is 3v minus 2w, which gives us 3 times 3i minus 5j minus 2 times negative 2i plus 3j, which gives us 9i minus 15j plus 4i minus 6j. And this is going to give us 13i minus 21j. So pretty simple, just like we did on the first slide. Now we're going to get into a little more unique ones, interesting ones. Those are kind of boring, actually. So we'll take the magnitude of v minus w. So the first thing we want to do is to subtract those. So when we subtract those two, we're going to get 3i minus 5j minus a negative 2i plus 3j. And when you combine that, you're going to get 5i minus 8j. Now we take the magnitude, which is just basically the square root of 5 squared plus negative 8 squared, which yields square root of 89. Okay, the next one we want to do find the magnitude of v plus w, and that's going to be that magnitude of 3i plus minus 5j. Again, you need to write these down. Negative 2i plus 3j, and you just combine them like we did earlier, and that's going to give us I minus 2j, and this equals square root of 1 squared plus negative 2 squared, which equals the square root of 5. Now in this one we have the magnitude of V minus the magnitude of W. So all you do there is we're going to take the magnitude of 3I minus 5J minus the magnitude of negative 2I plus 3J. So this all equals square root of 3 squared plus negative 5 squared minus square root of negative 2 squared plus 3 squared. And this is going to yield square root of 34 minus the square root of 13. Now, let's go ahead and add these. And so we want the magnitude of V plus the magnitude of W. And basically we're doing the same thing, but changing everything to plus. So basically, that's just going to be square root of 34 plus the square root of 13. So we're just adding them. All right? And the next video we're going to do is finding a unit vector.